On this episode of the Power Podcast, I'm joined by Dave Weinstein. He's the Chief Security Officer with Claroty, which is a cybersecurity company. And Dave, I'll have you give a little bit of background about the company and tell us what your expertise is.
Thanks, Aaron. Appreciate you having me on. So Claroty is a cybersecurity startup that is laser focused on protecting operational technology networks. So in contrast to most of the cybersecurity companies out there that focus on information technology systems, we're focused on the industrial control systems that happen to underlie most of our critical infrastructure, not only in the United States, but across the world. We've been around since 2015, been in the market since 2016, and since then we've grown pretty rapidly. We've raised $100 million, and we're currently deployed across 15 different industry verticals on 6 continents in over 25 countries. So suffice it to say, there's strong demand signals coming from a variety of industries, not the least of which is the power generation sector. And we've obviously seen a lot of interest coming from that space. We're definitely a global company. We are headquartered out of Manhattan, Midtown in Manhattan. We have our research and development out of Tel Aviv, but like I said, we are global with a presence in North America, in EMEA, as well as the Asian Pacific region.
And if I understand correctly, a lot of the people within the organization have come from military background, maybe working with Department of Defense or even with the Israeli Defense Force. Is that correct?
That is correct. I myself come out of the U.S. intelligence community. I began my career with the Department of Defense, specifically U.S. Cyber Command, and a number of my colleagues at Claroty come out of the same world, albeit many of them out of the Israeli Defense Force. The point being there that, and I've said this many times, sometimes in order to really understand how to protect these networks, you really have to have your finger on the pulse of the threat landscape. And having served in the intelligence community, many of us have a pretty good understanding of what the threats are, and more specifically, how bad actors are exploiting these networks for different purposes. So we incorporate that thinking, if you will, into how we build our product.
Yeah, I was thinking that was probably a pretty important background to have, because at least from what I've heard, there's a lot of, I guess, government entities out there that are hacking into computers, or at least exploring ways that they can perhaps leverage this information, such as from North Korea, China, Russia. We hear these things all the time. So where do you think the biggest threats lie, and who is behind the scenes working on these types of things?
So our assessment is that with respect to industrial control systems, nation-state actors continue to monopolize, if you will, the threat landscape. That is to say that the barriers to entry are sufficiently high enough at this point to prevent, your average script kiddie or high school hacker from doing serious damage to, for example, the electrical grid. The usual suspects are the folks you probably read about in the media: China, Russia, North Korea, Iran. But our observation is that those barriers to entry that I referred to are slowly but surely falling, to the point where in the next couple of years, we may start to see non-state actors penetrate this threat landscape, which of course is a troubling scenario, because it's much more difficult, if not impossible, to deter non-state actors. So this is kind of a product of a number of things, one of which, one of the main factors contributing to this trend is that these networks, which have historically been entirely isolated from the internet, are increasingly connected by way of corporate IT networks. So think about, a Fortune 500 company with, significant operational technology footprint. They also have a business network. They also have, kind of your corporate IT network. Historically, those two networks have existed on isolated islands, if you will, but increasingly they are now connected, which means through the IT network, folks out there on the internet could theoretically gain remote access to critical OT systems. Now, the factors driving this connectivity, what we refer to in the industry as the convergence of IT OT, are largely business requirements, right? Just given the potential to improve efficiencies, and perform data analytics has driven more and more of this connectivity between IT and OT. Our assessment is that it's only going to grow more connected with time, which compels organizations to think really proactively about how to deal with this phenomenon. And quite frankly, the first step is gaining really deep visibility of the assets on the OT side of the house. What once was a trusted network can no longer be trusted. So you have to understand exactly what's on your network in real time. And similarly, you have to understand how all those devices that are on the network are communicating with each other and potentially with external assets. And the reason for that is these are largely machine-to-machine communications. When you're dealing with industrial control systems, they are communicating in highly predictable ways. It's repeatable. There are lots of patterns. Deviations from those patterns are typically indicative of either a malicious threat or some sort of operational anomaly. So because of this hyperconnectivity between IT and OT, owners and operators of these systems, whether they be a power generation system or a manufacturing facility with all sorts of operational technology assets on their network, they have to understand what's going on in that environment in order to secure it.
What does a company like yours, what are you providing to a power plant or to a power company that helps them get this deeper look? I mean, is it a software solution or is it some other sort of monitoring system?
So our product is a software solution, right? And what we do, without getting too technical, is we perform something called deep packet inspection on all of the network's communications. And by doing that, we're able to, at a very granular level, understand the communications between all of these devices and parse their protocols. So unlike IT systems where most of the traffic travels across open protocols, OT systems communicate using closed protocols that are often proprietary to the vendor itself. So if you throw a typical IT security monitoring solution on an OT network, you're just not going to see anything. You're not going to be able to, you'll capture a bunch of traffic over the wire, but you won't be able to read it. You won't be able to understand it. Our solution provides not just that depth of visibility, but the context of the communications so that at the end of the day, an end user, whether it be an IT security analyst in an enterprise security operations center, or just a OT engineer, or on the floor of a power plant, so they can understand and ultimately resolve security and operational events that the system generates. So what we do is actually push all that information to whoever the end user is, so they can make decisions and ultimately perform actions to mitigate risk associated with the network.
Now, I know most companies that are basically doing the original equipment manufacturers, I'll say the GEs, the Siemens, the Honeywells, they have their own cybersecurity type systems that they use to monitor their networks, and basically they sell the same type of control to the power companies. So what sets Claroty apart, and why would somebody come to you for that type of service?
It's a great question. I think it's a really important distinction. So the security features that, for example, the OEMs like Siemens build into their products are separate and distinct from the solution that we bring to bear. In fact, it's why we're very proud to count three of the major industrial control vendors as investors: Siemens, Schneider Electric, and Buckwell Automation, all invested in Claroty's last fundraising round, which was not only very validating for us from a technical and business perspective, but it demonstrates that there is capabilities that we bring to bear that they don't, right? So they're entirely complementary. What we do is we monitor the communications between, for example, Siemens devices on a power plant's network, right? And we can do that because we understand Siemens protocols. We can parse those protocols and provide context to the end user with respect to that traffic, right? So it's actually a highly complementary relationship. And in fact, we have a number of integrations with vendors like Siemens where our software is just embedded on their hardware, for providing additional level of security for our joint customers. So it's why we, again, not only are lucky to have them as investors, but it's why we count them as joint go-to-market partners. They're a big part of our channel program, and it's why we count them as customers as well. It is a highly complementary relationship.
When you think about power plants and having to meet all of the NERC-CIP standards and these type of regulatory requirements, does your service or does your software help meet some of those requirements, or is that above and beyond?
It does. It's not above and beyond. In fact, compliance, while we are hardly a compliance product, we absolutely take into account the compliance needs of our customers with respect to security. And I'm hardly a NERC-CIP expert, but we have published most recently a paper on how our solution can help customers achieve NERC-CIP compliance. And there's actually a very, very neat kind of mapping of Claroty's capabilities to the NERC-CIP requirements. So there's absolutely some efficiency that can be gained there for owners and operators to essentially kill multiple birds with one stone by not only achieving compliance with NERC-CIP, but also going above and beyond the standard with respect to certain security controls. So this is a big part of our value proposition is kind of being a one-stop shop for OT security, and compliance is a big part of that, which is why the Claroty platform addresses a variety of cybersecurity domains that are relevant to the OT side, to include, basic asset management requirements, which are, as you know, really important to the electric subsector.
My last question for you is are there any examples of specific things that your software has exposed in a power plant or in some power control system that you could share with us, and just kind of how the process played out and what was found and how you solved that problem?
Fortunately, we have not detected any major attacks against power generation systems. And I think generally speaking, the word attacks or attack is used fairly cavalierly in this field. We tend to set the bar pretty high. But when I say attack, I'm thinking, something along the lines of what the Russians did to the Ukrainians in 2006, or to the Ukrainians in 2016 and 17, resulting in about 250,000 people losing power for 6 to 7 hours across the two events. Luckily, we have not detected that type of activity, and God willing, we won't anytime soon. At the same time, however, it's rare that we enter a new environment and don't find all sorts of bad stuff, right? And sometimes that bad stuff can be characterized as, just kind of poor cyber hygiene, not necessarily indicative of threat activity, but all sorts of misconfigurations, kind of other suspicious or anomalous activity. On the other hand, we routinely encounter what I'll refer to as kind of commodity malware that has found its way onto these networks. And, commodity malware on an IT network is not really a big deal in most cases. You can quarantine it. Maybe you have to bring down, refresh some computers or wipe some hard drives or something like that. And then everything's back up and running. But commodity malware in an OT environment, as you know, can be quite problematic. And the consequences can be measured in both operational downtime, but also potentially dangerous situations. So we encounter that type of stuff fairly routinely. It's indicative of the hyperconnectivity that I referenced earlier, or the interconnectivity, if you will, which is essentially allowing this code to traverse the network and leak from the IT side of the house. So, of course, that's something we work with our customers to first detect and then, remediate without any serious impact occurring.
Well, that answers all of my questions. Is there anything that we haven't touched on that you think is still important to get out?
No, I think that's it. I enjoyed it. Thanks for having me on.
All right. Thanks for taking the time to speak with me, and I appreciate your insight.